Right, good afternoon and welcome to the latest in the UK and I webinar series. I'm joined by Dan Watson, who's going to be talking about all things Avi today. So welcome. Dan, if you could just advance to the next slide. Couple of things I'm just going to cover in Carl's absence. Obviously, Carl normally introduces these. One is just a few things to look out for. First one is VMware Explore 2026. No confirmed dates yet, but it will be November. So yeah, just watch out for the dates coming through, and obviously get your registrations in for that one. Next one, please, Dan. Then we've got a couple of events happening. One in January, so 2026. This is obviously around sort of the VMUG. So obviously, if you've got some interest there in the London VMUG, obviously, get your sort of event registration, call for papers, and then obviously there's some external links in there as well. So what I'll do is, while Dan's presenting, I'll just put some things in the chat just around the links, obviously, which you can grab. So yeah, just be aware of that. So that's early, obviously, in the new year. Next one, please, Dan. And then obviously we've got VMUG Connect in Amsterdam. So again, sort of March the 17th to March the 19th, 2026, in Amsterdam. So yeah, if you go to connect.vmug.com, obviously you can register for that event, and obviously the associated costs are on the slide as well. So next one, please, Dan. So what I'm going to do now is hand over to Dan. Dan's going to talk about Avi Load Balancer, the application sort of services fabric, and then I'll rejoin you at the end of the presentation just to finish off. So over to you, Dan.
Thank you, Richard. Okay, hi everybody. My name's Dan. I work in the ANS division in Broadcom, so sort of like a sister BU to the VCF team. So everything we're going to talk about today, we'll talk about Avi Load Balancer, talk about what Avi is, where it fits into the Broadcom portfolio, specifically around things like VCF. So we'll talk about what we do. If you think about VCF really and the way we integrate, that's our key sort of selling point really. So and what's probably important to say at the beginning as well is that what we're talking about today is an advanced service. So it's the stuff that you can add on top of VCF, and we'll show why we think that's so important that you look at adding Avi into the solution really at day one when you start to look at deploying VCF. So firstly, what is Avi? Well, Avi is an application services fabric. Think of it as a delivery controller. If you think of the term ADC, which most of you will probably be aware of. Load balancing is what we do. We're a bit more than a load balancer though, so we don't just treat ourselves as a load balancer. We talk about ourselves as a delivery fabric for applications. Okay, so we typically sit in line with applications, so we're already in the path of applications. So we're a brilliant place to be able to do sort of extra controls like layer 7 proxying of services back to the back end applications. That includes things like security controls, so SSL termination, re-encryption, those types of controls, and things like SAML authentication, so being able to authenticate users to an application in the back end. And those apps can be, they could be VM applications running in traditional vSphere estate. They could be containerized, running in something like VKS. They could be modern container apps in that sense, or they could be even bare metal applications just sat within your data center. So we act as really that point to be able to do application delivery. Make sure you've got good, reliable, secure access to applications. Being able to do things like let users know when a service is down and being able to redirect them to a sorry page, or maybe redirect them to a different site even. So if you think about our global services, we've got some capability for doing things like global server load balancing, etc. So that's where we sit in terms of the solution. Our differentiation, though, if you look at why is Avi different to any other application delivery controller on the market, then our differentiation is really that we're a split data plane and control plane. So if you know anything about NSX or VCF networking and what we've done there over the past sort of decade now, looking at what NSX does, we've split that control and data plane. So everything from a management, from a an orchestration from a logging, alerting, everything that you do from a day-to-day management perspective on NSX or VCF networking is done in the control and management plane. And then we push those services for, forwarding of data to a back-end service. All of the data plane services are run in the data plane inside of the hypervisor, if you think about NSX. Whereas, if you look at the similarities then to what we're doing compared to something like F5, if you look at that from an application delivery perspective and look at some of our competitors, F5, NetScaler, the traditional load balancing companies, they're typically a management and data plane sat in one box. So you typically deploy, maybe a big IP, whether that's a physical or a virtual edition, or a NetScaler appliance. You deploy them and you manage that box from that device. So the management component is the same as the data plane. So with Avi, what we've done is we've split that in similar ways we've done with NSX. So you have this control cluster on the right here. We have a control cluster, which is where we do all of the configuration of Avi and set up what we want to do from a load balancing perspective for different applications. And then these things called service engines are our data plane, which run on top of vSphere. Typically, if you're in a VMware environment or a VCF environment, that data plane would be running those load balancing proxy services to connect a user from a client device to a backend server, a backend pool of servers. Okay, so these are called service engines. They're our data plane object, and we have a control plane, and we just a control cluster essentially. Okay. So that's the main differentiation between architecturally what we do, but that allows us to do things like reduce the number of managed devices and massively improve the way we do simplification of your operational model, because you don't have to manage tens of 20 different application proxies, different big IPs or NetScalers. You do it through one interface and one control plane that then pushes those services out where they're needed in your fabric, in your data center. And we'll talk a little bit about why we call ourselves an application fabric in that sense in a couple of slides. So our main use cases, if you like, what we're designed to do typically, firstly, obviously local and global load balancing. So, our solution is built on one SKU. So there's only one product you can buy from Broadcom to cover all of this. So you buy Avi Load Balancer and you get all of the capabilities that we're talking about. So whether that's local or global load balancing, so things like being able to do local load balancing to a farm of servers, like a server pool or a web farm, or you could do global server load balancing, so you can have traffic going across multiple geos, or you can do, have one data center being your primary and your secondary data center being, your redundant data center, or you can share the traffic across them. And we handle all of that sort of global traffic management. So you might be familiar with, our competitors, GTM and LTM in that space. And then we go on to things like, more advanced capabilities around web security. So from an application security perspective, how do we protect against your web apps? And we've seen some massive increase in using our application firewall, so using WAF on top of Avi to protect web applications within our large financial companies. So a lot of our financial customers are moving towards being able to deliver full web application firewalling across all of their applications. And Avi becomes a really good place to do that, particularly if you're rolling out VCF. And we can talk a little bit about why that is. Some of these, by the way, we won't cover all today. We'll cover them in subsequent sessions where we can start to go into more detail about, things like global server load balancing could be another session, or we could cover WAF and application security as another session. What we will cover today, though, is looking a little bit at what we do around application visibility, which is one of the key areas for us in terms of Avi, is being able to provide really fine-grained, very detailed analytics and application visibility to give you, a view of what's happening within your load balancer estate. So a lot of our customers have traditionally told us that, their existing incumbent load balancer doesn't give them really any visibility. They treat them almost as a black box. So they don't know if there's a problem. They don't really know where that problem is. Get a call from a customer saying, we've got no access to our application. So what we do here is give you some insight into what we do with Avi and give you some visibility of how applications are running. So we'll talk about that today. And then one of the other sessions that we could probably run in the future is about what we're doing for things like ingress for containers. So if you look at Kubernetes is, as you're probably all aware, huge growth area for not just VMware and Broadcom, but lots of customers were seeing deployments of container functions, whether that's telcos or container functions running in finance organizations, and applications moving to this containerized Kubernetes-driven application. Not to mention, if you're not already familiar, that Kubernetes is a big part of what we're doing from an operational perspective with VCF. So essentially, using Kubernetes to orchestrate and manage your vSphere or VCF estate. So Avi becomes key to how we deliver ingress or load balancing for Kubernetes applications, including the supervisor cluster that manages VCF. So a little bit about where we sit in terms of the ANSBU. I said that we're part of application networking and security within Broadcom. So application network and security, we own two products essentially. We own vDefend, which is our gateway and distributed firewall product, which is sort of down here in the left, and then we've got the Avi product, which is our ADC, or our delivery controller, delivery services fabric. So if you think about that, we typically see customers using vDefend for segmenting, for doing advanced threat protection against, threat analysis against applications running in your VCF estate. How do you make sure you do true control and east-west security from a segmentation perspective and look for network-borne threats? So we've got some sessions. I think Atif, one of my colleagues, is doing a session on vDefend in January, I think. So that's something you could look at this side of things. And then what we're talking about today is really application delivery. So where we sit is more being able to look at traffic coming into a VCF environment. How do we deliver that traffic to applications running on top of VCF? But it could be other operating systems as well. It could be other solutions. You could run this on top of Google GCP. You could run it on Azure, or you could run it on AWS. What we're talking about typically today is more VCF integrated and how we do that. And we'll talk about how Avi allows you to build a services fabric that scales, how we give you unparalleled visibility, and how we do that with automation as well. So we'll cover some of those at a high level. So firstly, why is orchestration and why is an API so important? So what we're hearing from most of our customers, particularly with moving towards VCF, is that automation becomes more and more important. It becomes, if you look at what customers are using, they're using typically something like ARIA automation, or they're using something in the future with VCF 9, using something like VCF automation, or they may be using Terraform or Ansible to spin up new services and manage that environment. So whether, and that's all driven essentially by consuming an API, and whether that's you're consuming it through something like Terraform or Ansible, or one of our tools like ARIA automation, or whether you want to build your own using something like Python or Go. We've got SDKs for those as well. What we're trying to show here is that everything within Avi is consumable, essentially driven through APIs. Whether that's the GUI, if you just look into the UI, the Avi UI, you'll be essentially driving via a lot of API requests. So if you go into the developer console within a UI, you can see those requests quite easily to see that actually what we're just doing underneath is calling an API or using the API request. And similarly, if you're into the command line, you're still just driving the API at the back. So it's everything. our UI and our CLI is just a client of the API at the end of the day. So everything you can do in Avi can be orchestrated through APIs is essentially what we're saying, which gives you a lot of control and a lot of power that you can, build something through the UI and then quite quickly and easily take that and deliver that as an automated service. And we do see a lot of that. Customers driving what we call load balancing as a service. Quite often, you want to be able to spin up a complete solution by just letting an end user drive something to a catalog, whether that's a VRA or VCF automation catalog item or something you build yourself through some sort of web portal. But that's what we see a lot of our customers do with Avi. And Avi makes it very, very easy to do that because of its full sort of API front end. So let's talk a little bit about architecture for Avi, because, to understand Avi, you need to understand what the architecture is and how we drive Avi underneath. So firstly, we have, a few components here. So we've got the control plane, as I said. The control plane sits in its own management plane, typically sits next to VCF networking, so next to, what's traditionally NSX manager. It sits in that same space as that. So these controllers sit in a management plane, if you like. Could be completely split and isolated from a network perspective as well, to give you security, to make sure that this control plane is more or less completely isolated from the data plane. And then the data plane, when we deploy in VCF or in vSphere, these service engines here, this application services fabric, is essentially VMs being deployed into your VCF fabric. So these would end up on ESXi hosts as virtual machines, and they are. The key difference for us is they are deployed via the control plane. So you don't ever in Avi have to go and deploy a load balancer. You don't manage a load balancer as such. You manage the applications that are running on top of that. So your view of the world is application centric. It's not going and managing a specific device which is load balancing a certain number of applications. You manage the control plane and then allow Avi to control the distribution of these service engines across that fabric. Hence this idea of a services fabric, because we deliver these application services that get distributed across your VCF environment. And the control plane is intelligent enough to work alongside vSphere, VCF, and vCenter essentially, and NSX Manager, to be able to orchestrate all of that and allow you to really just drive it through a GUI or through an automation. It could be a script or it could be something with VCFA. So these service engines get deployed. They are identical in terms of their form factor, or not form factor, but identical in terms of their code, whether you're deploying this on VCF or whether you're deploying it in AWS or GCP. It's the same service fabric. It's the same type of load balancer. It's running as an instance in AWS or a VM in vSphere, and then we can manage them centrally here. So as well as managing local VCF components and local VCF service engines in your fabric, we can be managing from the same control plane. We can be managing services running on AWS or GCP. So that gives you this idea of multi-cloud. But really, what we're focusing on today is how we run on VCF. A little bit around Cloud Console. This is our, if you like, our SaaS component. So if you allow to connect to the cloud and you allow the manager to have connectivity, very secure, very small amount of data that we pass back to the Cloud Console. But this allows you to share licensing across multiple control planes. If you've got 2 or 3 control planes, maybe one in Europe and one in Asia Pac, we can manage them through 2 controllers, but they can be license managed through a central point. But this also supports things like threat feeds being deployed to these control planes. You can still deploy them manually, but that gives you some more centralized threat feed, easy to deploy services rather than having to go and pull them down manually. Okay, and then each of these service engines is responsible for forwarding traffic or proxying traffic. More importantly, typically acting as a proxy to proxy that traffic to a back-end web server. So you've got a client connecting to a VIP on a service engine, forwarding to or proxying to a service at the back end. And then these are scalable as well. So when we talk about elastic scale, these service engines can scale out. Hence, we've got one in this group of service engines. It's not really a group, it's only got one. We've got two in the middle, and we've got three on the right here. And they can scale up hugely to give you massive scalability if you really need it. And the idea here is that when we run active, 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 in this case, that application that's running will be scaled out across the service engines. So if you lose a service engine, you're only losing, in this case, a third of the application traffic for that application. And then Avi will automatically heal itself, which we'll talk about in a minute. So, and these service engines are also collecting load of data, log data, analytics data, and then passing it back to the control plane, which then does a load of analysis of that data and presents it in the UI, which we'll show you through the UI in a few minutes. So a quick intro to what we're doing around VCF, because VCF is pretty important as we move forward, as you're probably aware. What do we do around VCF? So what we're doing now, particularly with moving forward to VCF 9, we're a bit more opinionated and a bit more prescriptive about how you deploy Avi in a VCF 9 environment. So VCF 9, we're sort of, predicating, if you like, that really when you deploy Avi, it's deployed as part of the VCF fabric. So in that case, your SDDC manager, or in VCF 9, your fleet management will be not only deploying the VCF workload domains, but it will also be there to deploy Avi. So it will deploy the control plane. It will then provision Avi into the workload domains. And then we'll do things like password certificate, password rotation. And then in the future, we'll start doing upgrades as well of that. So you'll essentially have a full upgrade lifecycle for this solution running in, for Avi running on top of VCF. Become so integrated into VCF that you don't have to upgrade Avi separately. You just upgrade Avi as part of the VCF upgrade. Okay. And then just a little insight to what we're doing from a networking perspective, because this is probably one of the key areas that differentiates, again, from our competitors, in that what we've built with Avi and the control plane is very strong integration, API-driven integration. Yeah, so it's done at an API level between the different components in VCF, but the Avi controller is so integrated into VCF that we're now able to deploy these service engines, which are essentially VMs, into your VCF fabric. So these will be running on ESXi hosts. So the control plane will essentially talk to vCenter and NSX Manager and deploy those service engines into this physical hypervisor fabric. It will also then auto plumb all of the networking. So your networking will just be connected. These service engines will be connected to the correct port groups or the correct NSX segments. It will be advertising a VIP range for all the applications. So when you have a VIP, it will just be advertised automatically through NSX integration. So when a VIP spins up on one of these service engines, or all of them, if you've scaled out that application, NSX will be informed of that by Avi, and then NSX will push that routing into its data plane. And then we'll advertise that into your T0s and your T1 and T0s using internal routing in T1, and then BGP into T0. So all of that advertisement is done for you. So you don't even need to worry about routing. You don't have to think about BGP. As long as your fabric is built correctly from day one, then all of that advertisement, scale up advertisement, scale down. How do we then, when another service engine spins up, how do we make sure that that VIP is available across all of them? That just happens because the control plane of Avi will make sure that the data plane in NSX is aware of it, and it will just be automatically delivered into the data plane. So then we talk about, that's one thing, but then auto scale is important, auto heal. If we have 3 service engines running here and one of them dies, what happens? So if we look at our auto heal capability, and in this case we have 3 service engines here, all running these blobs here, different color blobs, indicate different applications running, or different VIPs, if you like, running across your scaled out fabric. And if one of them dies for any reason, what Avi will do from its control plane is it will just spin up another service engine. If it's not already got available space, if it's got capacity available, it will just do it within the existing capacity. But if it needs to spin up another service engine, it will do that. It will create a VM, spin that up via vCenter into a hypervisor. It will make sure that it's evenly balanced. And then the services that were running on that dead service engine will just automatically be moved across to another one. And we'll scale those across service engines to make sure that they are evenly distributed. And you can do rebalance that at any point if you want to rebalance those workloads or those applications. And then finally, we've got this tenancy model as well. So if you've got different departments or different organizational units within your organization, you want to split them into different BUs or different owners of different apps, then we can do that with a tenancy model as well. So our tenancy model allows you to essentially give a end user or an application owner access to all of the Avi logs and the Avi GUI or the Avi UI without having to give them full access to the control plane. So all you're giving them is essentially read-only access to be able to see their VIPs, see their applications, and get some insight into how they are running. Okay, so that's what you do in terms of sort of our fabric. It gives you this capability of scaling out, scaling in. So these are dynamic. You can scale out and scale in an application based on its bandwidth requirements or its TPS requirements. And then we can also we can do multi-tenancy to be able to have different organizational units having their own applications, their own view of them. So what we're going to do now is talk about analytics and observability, but rather than do that through PowerPoint or a presentation, here's what it sort of looks like. I think it's easier just to jump out of here and jump into the UI. So if we can all see that still, hopefully you can. Here's our UI, if you've never seen it before. And the first thing is that it's very application centric. So what we're seeing here is applications running within the control plane or what the control plane has access to. So this is a little bit, we've only got two applications here, but this shows you our tenancy view. So if we look at a different tenant and I pick on the demo tenant, for example, what we'll see here now is, we've got a number of applications running within this environment, okay? And the first thing is this is like the health score. So what we're doing is some analytics to be able to show you how well that application is performing. So right from the get-go, without even having to do anything, you can just log into the UI, or one of your application owners can log into this user interface and see how their application is running. So if I'm the owner of Avi Demo, I can see that it's orange. I maybe have some issues, but it's still running. It's not down. It's still operating, but it's got a degraded performance. It's not running at 100. If I'm the owner of Scale Out Auto, then everything's great. Everything's fantastic because it's running perfectly well. I don't need to worry about it. So from this point, you can get just very clear view of how things are operating within the estate. And then we have some sort of information here, metrics that you can just hover over to get a view of, what's the RPS for this application, what's the open connections, and that gives you a little chart as well as to how it's been over the past 6 hours and sort of the throughput of the application. So we can add more columns to this. If you wanted to add things into this column, you could add the service engine, and then you'd be able to see which service engine those are running on as well. If you want to see which actual VM is load balancing that application. And it could be multiple, if you've scaled out that application across multiple service engines, we'll be able to see the service engines that are managing that service. So here you'll be able to hover over and look at them, and you can click on them if you want to at that point. Here's the VIP itself, the virtual IP that this service is listening on. So if you want to go to that IP address, you'd get to this application. Okay, and then you can hover over here, and it'll give you a little bit more detail about what we've analyzed and what we're showing you. So we've got a penalty score there. You can see at the bottom that's -20. The reason that penalty score has been added is because we're using a self-signed certificate. So we automatically score your application down if you're using self-signed. You've got a resource penalty. So that typically, in this case, it might be because a pool member is down for any reason, maybe one of the VMs at the back end, one of the, if you've got 4 or 5 servers in the pool. Maybe one of those servers has died and it's running a little bit degraded in terms of its performance for that application. Anomalies are, things that happen that are not normal. So, the idea of this analytic-based system is that we're looking for things that are not normal. So anomalies are something that you probably want to go and look at if you've got an anomaly score, because it's something that's not happening typically as usual. So that's just sort of this front end, and it already gives you some information. Now, what we can then do is we can go into an application. So we can dive into this Avi demo, and we get a little bit more detail here from how is this application running? Is there anything we need to look out for? So this is sort of our, we like to call this our mean time to innocence chart. We've been calling it that for years. Mean time to innocence being that, generally what we see with our customers that aren't using Avi is that when you have an issue with an application, whose responsibility is it? Whose fault is it, if you like? And we end up with this blame game that, networks say it's not me, and application teams say it's not me, nothing to do with me. What we're seeing here is sort of like a little view of all of that in one chart. So what we're seeing here is the green bit at the bottom is more or less the network response time or network responsiveness for this application. And although we've got a few little peaks and bits, it's a bit jagged, but it's pretty consistent in terms of the network throughput. So that's almost like the client to load balancer, the client to service engine sort of round trip. This looks fairly static. So we're not seeing any major network issues in the environment. The yellow bit is more the application response. So we do a couple of things. One we do, we measure sort of, the round trip of the application, the service engine to the back-end servers, but we're also measuring like the application responsiveness. So here we can see app response time. So we'll see that, this changes between here and here. And you can see that the app response jumps up when we get to one of these applications, or one of these peaks. So we can see that, we're introducing a latency for that application. You can see that here. So by just looking at the color, if it's yellow, we're more or less saying, well, that's more of an application issue. So it could be that there is a server down, the back-end server, or it could be one of the pool members is down, or the service is down at the back end. And that will affect your, essentially this timing chart. So this is generally a very good chart just to give you a view of how things are running. And from here, you can see that every so often we have an increase in latency. Actually, what we do in our demo to show this is we just turn the server off. We turn a VM off every few hours and then turn it back on again. So you can see that there's an increased latency because we're running now load balancing across a few servers rather than 5 or 6. Okay. So, and also we can see the pool health here, and we can click on these. We can see the end-to-end timing for this application. The throughput, fairly consistent. Look, there's no real peaks here. And the open connection. So you can start to scroll down and look at all of these different, even things like HTTP versus HTTP2 requests. I've got, is this application using HTTP2 or just HTTP? So you've got a view of lots of different metrics just here. And these are sort of analytics that are pulling these metrics together. So then we go into more login. So if we look at the logs and start looking a bit more in detail at one application, or this application, and what's actually happening from a request perspective. So when somebody is, from a client perspective, going into their browser and accessing this web server, what are we actually seeing? And here we can turn on, this is something that we, with a lot of customers, you turn on all of this login, particularly when it's sort of a new application. It gives you a lot of insight into how the application's running. And then maybe you cut back some of this to save on sort of log space in the future. But the idea is here we're pulling all of these logs back about exactly how this application is running. So these are transaction by transaction requests. And our customers typically use Avi now say we don't have anything like this from our competitive incumbent load balancer. We don't have any of this visibility, or to do it, what we have to do is raise a ticket to be able to give ourselves some level of admin access. Then we have to turn on some sort of packet capture, and we have to take that packet capture and put it into something like into Wireshark, and then we have to analyze that traffic. Whereas when they get into Avi and they look at this, they go, well, it's just so much easier. It saves us hours, if not weeks. I was talking to one of our financial customers. This is saving them literally weeks when it comes to a particular pattern of traffic that they're trying to troubleshoot, because of the amount of change requests that they have to put in to enable something like a traffic capture. It's not just, they can't just turn it on, they have to get a traffic capture allowed before they can do that. So this is giving so much more information, and we can see here there's a set of logs, so you can actually just hover over here and pick a window of time that I want to look at, and then it will filter these logs just to this window of time. And then we can say, right, well, now that I've done that, am I looking at significant logs or non-significant? So significant versus non-significance is, significant is something that you really want to look at. Obviously, it's more logs that we think you should be looking at. So more significance. Non-significant is like everything. So if you turn on this, you'll get more logging coming back, or more of that. We'll see more logs because we're showing you everything that's happening for that application. And then we can start to then drill down into these different individual logs. So we can see here that this was an IP that connected to, that went to a URI of header.png, was a GET request. We got a 200 response, what its length was in terms of the request length, and then even each duration. So how long did it take to service that request back to the user? So quite easily, by looking at these here, if you just look down here, you can actually start looking at the outliers, which are the ones that are taking longer. And then if we click on some of this client analytics down here, we can actually start seeing some of these things in as an analytics view. So you can actually start saying, well, just show me the server addresses that are involved in this application. These are the 3 pool members for this application, and yeah, it looks like they're load balancing fairly evenly. Yeah, this one's taking a little bit more traffic, but it's fairly even. And we can look at the service engines. So this service is running across these. Is it 2 or 3? Can't remember. It's running across these 2 service engines. So you've got 50% roughly of traffic being directed across each service engine. So we're seeing not only that the application is being load balanced, but also we're load balancing the traffic to the load balancer. Yeah. So we're distributing the traffic across our own fabric to make sure that we don't have just one service engine dealing with all of that traffic. And therefore, if you're scaled out, then you've got this ability just to keep scaling and distributing that traffic more and more across service engines. Brilliant for things like WAF use cases. If you're running application firewalling, which is quite compute hungry, the ability to scale out across these service engines is fantastic, because then you can just, as the growth of applications and you're doing more and more WAF analysis, then you will need more compute, but you can just scale these across more service engines. And then if we look into the logs a little bit more detail, we can actually start going down and drilling into these individual logs. Yeah, this is the IP address it came from. This is what the VIP we sent that traffic to. We can see which service engine. We had multiple service engines, so we can see which service engine dealt with this particular request. And you can also see, if you want, which actual CPU within the service engine dealt with it. And then where did we send the traffic? We sent it to this pool member here at the back end on this port number. And then we've got data that is really useful particularly if you're a dev. So some of our customers who've got dev environments and dev teams, they find this really useful for like troubleshooting and helping them understand how an application's working when they're starting to roll out an application. Where's this user coming from? Well, we've done some geolocation. So we know this actual request is coming from the US. It was on a Windows 8 machine, and it had perfect forward secrecy enabled. It was using IE. So, and then we can see, the persistence IDs as well. So we can manage persistence across multiple service engines. So you've got some persistence tracked across service engines. And then where do we send that traffic to? So which host do we send it to? what was the target URI, etc. And then we've got some policies. So policies for us, things that rather than having to create lots of I rules, maybe if you're an F5 user, or application rules, then we can do these within policies, which is essentially GUI driven. So you can click in the UI, you can say, I want to enable SSL to the back end, maybe, and I want to make sure that if I get a GET request for this particular path, I want to forward it to a different content, a different pool, for example, so I can do a content switch. So all of these types of application policies are applied here, and we're showing you which ones are applied. So for example, we've applied SSL. So for this log, all of this traffic is SSL encrypted. We've got this authentication. So we're doing some SAML-based potentially authentication at the back end, at the front end of the VIP. So when the user connects to the VIP, we're going to challenge them for authentication. We're not doing ICAP. ICAP is inline virus scanning, if you like. We've not got WAF enabled, but if you turn WAF on, very simple to turn WAF on this application, then you could just enable more application firewall and protection. If that's, like I say, we're seeing a lot of customers that have got compliance requirements for needing some sort of application firewalling on all their applications. Similarly with bot management, I'm seeing a lot of customers that need some form of bot management to detect when, is it a good bot? Does it look like a human interaction? Does it look like it's a bot? And if it's a bot, is it good or is it bad? So we can detect that as well. And then data scripts, finally, our ability to do more advanced policies, if you like, but doing through a script. So, if you were migrating from another product and you had a really complicated set of, iRule, for example, and we can do it with a policy, then you can create a data script, which is essentially the equivalent of an iRule. Typically, though, we only need data scripts for a small number of applications. Usually, about 85, maybe even higher % of the applications that move across will just use policies rather than iRules. Okay. Then, if you want to go into the full log, you can click here, and we give you even more information. The actual timing for this particular request. We can then go into, again, that information we've seen before, but we can then start going into the fingerprint itself. You can see that and click on there and get more detail. We can even see the headers. So this is really useful. Go into the request headers and see what was received by the service engine and what we forwarded or what we sent to the server. So here we're doing X forwarded for. So you can see that the X forwarded for IP of the machine was added through the to send it on to the back end. So we're doing we're showing you essentially the HTTP headers here, and then you can see the response headers as well. So we and then things like JWT, etc. So we've got so much information in here, and that's just a quick intro to what we can do. So I'll stop there because I need to conscious I've only got a couple of minutes left. So that's just a quick highlight of what we can do. Let me just go back to the presentation for a minute and just finally finish off. So I won't go through these because we've already covered that. So summary wise, Avi is think of it as an application services fabric. Think of it as a load balancer, but more than load balancer, we've got a load balancer that scales across your VCF environment that allows you to automate everything. Our key use cases, if you like, are local and global load balancing, WAF. We talked about WAF. Hopefully, we've shown you a bit about the application visibility and how much visibility we give versus a lot of the other products out in the market. And then finally, something that we probably need to touch on as another session is how we do ingress for Kubernetes, which, as I say, is becoming a very key area for us. And we've got some users that have been using Avi for Kubernetes load balancing for sort of 6 or 7 years. Yeah, we were quite early to that space. IDC just shows you about the sort of the reason for doing it. There are really good case references about how we've reduced total cost of, how you reduce the operational costs, 90% faster to scale capacity, 6 months payback in some cases for low cost of operations. How do we reduce that operational challenge by having everything in one control plane where you can manage it through either through that UI or manage it through something like a automation through Terraform or Ansible, etc. So there are some really good keys. So if you want to talk to us about some real use cases of how we've saved customers money and how we've got a return on investment, especially by adding this into VCF at day one, how do we do that? Make sure we migrate to Avi from some of their incumbent load balancer solutions at that point and deliver a full true private cloud with delivery, application delivery included. So you can go and play with Avi, go and have a look at our webinars. We've got some webinars, we've got the hands-on labs, and we've got our docs. But we do regular webinars where we go into a lot more detail. Full day. I think we do 2-day workshops that you can get on and have a look at exactly how Avi works. Get a lot more into the weeds of how we spin up Avi and how we manage and operate it. And then I think finally hand over back to Richard just to close off. So thank you very much, everyone. For me, have a lovely Christmas and have a good break, and hopefully get to speak to you in the new year.
Yeah, brilliant. Thanks, Dan. That was a great session. So as Dan said, if you've got any questions, I mean, there was none in the Q&A, which is probably a first, but if you've got some questions, please reach out to your account teams, who will obviously be more than willing to talk to you about Avi, and obviously take it from there. So yeah, a couple of things in terms of hands-on labs, they're available. There's probably going to be some content in there around Avi, so if you wanted to try it and play with it yourself, please do so. And then the second link there is really obviously for this webinar series. So if you want to share that with your friends and colleagues, then please do that and do so. And then we'll see you next month. So this is the final one this month, and then we've got I think the next session on the 30th of January. So at the end of this, there will be a survey. So I appreciate it if you could go through, complete the survey. It's only 4 questions, and then maybe some suggestions on what you'd like to see as a further session. So yeah, to Dan's point, have a great holiday, have a great break, and then yeah, we'll catch you in the new year. So thank you very much.